Assalamu alaikum.
Slide number 2, normal distribution. This is the most important probability distribution applicable on continuous data or continuous variable. Whenever we are dealing with continuous variable and we are going to analyze the data, it is very important to know whether the distribution pattern of the observations of that variable is normal or it is not normal, because the types of the tests which are used for the analysis, they are different in case of normal and in case of non-normal. It is applicable only on continuous variable. This is also known as Gaussian distribution. Carl Friedrich Gauss was a German mathematician. He developed this normal distribution. That's why it is also named as Gaussian distribution. So in this lecture, we are going to discuss about the normal distribution, and we shall be solving some problems and some exercises on normal distribution.
Slide number 3. Carl Friedrich Gauss, the person or the scientist who developed this normal distribution. There is a very interesting story about him, about his intelligence at the childhood age. When he was in school, maybe in 5th or 6th standard, then in his class one day, one child was creating some problem or just doing some naughty things. The teacher punished that child, and he asked that child, okay, you take your pen and paper and go and sit in that corner and add these numbers, and when you get the total, then you will be allowed to sit on your class seat. Okay, that child who was punished, he started doing that one. Within 2-3 minutes, Gauss, who was also a student of that class, he gave a slip to the teacher and he get the total. So teacher was surprised and he asked, how did you do it? So I am showing that how he managed to do this one, adding the numbers from 1 to 100. He wrote S, that is S is to be calculated, 1 plus 2 plus 3 up to plus 100. Then he wrote the number in reverse order, 100, 99, 98 and 1 below 100. And he added these two equations. So 2s equal to all are 101, 101, 101. That is 2s is equal to 100 times 101. And therefore S equal to 100 into 101 upon 2, the 2 on the left side will be on the right side, and that is 50, 50, 50, 50. So this is what he did when he was in a school, 6th or 7th standard. That is, the formula here is, if you want to add numbers from 1 to n, then it is equal to n into n plus 1 by 2. That is, if you want to get a total of 1 plus 2 up to 25, then it will be 25 into 25 plus 1 means 26 upon 2, and this total is equal to 325. So this was his story. Now, using this formula, how some good MCQs or some good questions can be made. I am showing one question, and be prepared for these types of questions in the examination. This formula has been explained to you. That is, adding observations numbers from 1 to n is equal to n into n plus 1 upon 2. This is the question. Sum of the sequence from 17 to 30, that is 17 plus 18 plus 19 plus 30 is, you have to select the correct one. The formula is only is for starting from 1 to any number, but here the question is for 17 plus 18 plus 19, starting from 17. What would you do here? Okay, I am explaining that one. you can get from 1 to 30 total equal to 465, and you can get the total from 1 to 16 using the same formula, 136. Now if you subtract 136 from 465, it will remain the total from 17 plus 18 plus 19 to 30. That is, this will be equal to 465 minus 136, that is 329. That is, the correct answer is 329. Okay. Now let us come to the normal. What is the normal distribution? This was, we were just discussing the person who developed the normal distribution. Now the normal distribution. Slide number 4. We have been explained histogram when we were discussing the graphical presentation of data. That is, histogram displays the distribution pattern of a continuous variable. Here we have taken two types of histograms. One is showing the age distribution of 250 persons, and the other is showing the diastolic blood pressure distribution of 250 persons. If you see in the age histogram, the most of the values, most of the persons are aged below 28 years, and there are some extremes, some of them are up to 80 years and so on, as that histogram is giving that idea. The mean is 30.68, but most of the population of most of the persons in this sample are aged from 14 to 21 and then 21 to 28. That is not 30. 30 is on the right side of that one. This is one histogram. The other histogram is that the majority of the persons are having blood pressure in the center. The average is 679.42 here. And as you are deviating on either side of this center, the frequencies are coming down. So the above histogram, it is a non-normal population. And second one is the normal distribution. Means normal distribution is that distribution where as you deviate from the central value, most of the values are clustering around the central value, and as you deviate on either side of the mean, the frequency or the curve is coming down. If the distribution pattern, most of our variables which we are dealing with, if you take the height, if the average height of the male is say 5.7 inches, then you will find most of the males, adult males, within 5-10 centimeters, and as you move ahead from the central value, then frequency will go down. Very few will be less than 150 centimeters, and very few will be more than 180 or 190 centimeters. So if the distribution pattern is of this type, this is known as normal distribution, but it should satisfy certain conditions. Only then we call it a normal distribution. Okay. Slide number 5. Normal distribution actually is the most important distribution in statistics, and it is applicable to the continuous variables. There are some properties of the normal curve. If you draw a curve, you have a large number of observations, and you can draw the histogram, and if you join the midpoints of the histogram of the upper surfaces of the bars of the histogram, it gives the curve like this. So this is there are certain properties of the if a variable follows a normal distribution, it should satisfy certain properties. The shape of the curve is like a bell, as it is shown here, always, as we saw in the histogram, that at the center the curve was having the peak highest, and as you deviate away from the center on either side, the curve was going down. Mu no is the population mean, that is mu is at the center, and it is if you deviate, it will go down. Another important property of normal curve is mean, median, mode are equal. That is, they all three are same. The second property of normal distribution. Okay, there are some more properties, and you are supposed to remember these properties. It's a bell shaped and mean like this curve, and mean, mode, median are same. Slide number 6. Property number 3. The total area under the curve above the x-axis is taken as 1 square unit, and 50% of the total area is on the right side of the mu and 50% on the left side of the mu. That is, if the mu is here, should draw a perpendicular here, then 50% area is on the left side and 50% on the right side. So this is the third property of the normal curve. Okay. Because the total area is 1, and therefore 0.5 to the left of mu and 0.5 to the right of mu. Okay. Slide number 7. In the last lecture, not class, before that one, the measures of location, and after that measures of dispersion, mu was taught to you, x bar or mu in the measures of location chapter, and standard deviation was explained to you in measure of dispersion. So we are also making use of the standard deviation here. Another property which you are supposed to know or remember this is the area. If a variable follows normal distribution, the area within the 1 sigma limit, means the area enclosed by perpendiculars at a distance of 1 standard deviation, that is 1 sigma, on either side of the mu is approximately 68.26%. What does it mean? Mu plus minus 1 SD. So this is the area out of 1, if you present as in proportion, 0.6826, means if they are also known as 1 sigma limit. On both sides of the mu, if you go up to 1 sigma distance and you erect the perpendiculars, and then the area within the two perpendiculars will be 0.6826, means say this is mu plus sigma and this is mu minus sigma, and you erect the perpendicular here, then this area is 68.26. And another important thing I think I forgot to tell in the last slide, that the curve is symmetric about the mean. What does symmetric means? If you fold the paper, this curve on mu, then the curve on the right side will fall exactly on the left side line. That is, if you are moving at the same distance from mu on the left or right, the area between the two parts will be exactly same. Means half of that one, 34.13%, will be on the left side, and 34.13% will be on the right side. Or if you present in the proportion 0.3413 on the left side and 0.3413 on the right side. And because the total area is 1, 0.5 on the right side, 0.5 on the left side, you can get what is the area beyond mu plus sigma, and the same area will be below mu minus sigma. So this is 1 sigma limit, and you must remember that the 1 sigma limit of the normal distribution cover 68.26% of the observations of the total area, and they are called 1 sigma limit, mu plus 1 sigma, mu minus 1 sigma. Slide number 8. Similarly, 2 sigma limits also cover a specific area, that is the area enclosed between 2 sigma limits, means mu plus minus 2 sigma or 2 SD. The area between these two limits is 0.9544, that is 95.44%, and mu plus minus 2 SD, it is known as 2 sigma limits. 1 sigma limit includes 68.34% area, 2 sigma limit cover 95.44% area. What I mean is that if mu plus 2 sigma is here, mu minus 2 sigma is here, if you draw the perpendicular here, then the area between these two is 95.44%, because the curve is symmetric. Area on both sides of mu will be same, and therefore you will also get the area outside these limits, because you know the total area is 1. Okay, if you are putting in percentage, it will be like this. Also 3 sigma limits. The area within 3 sigma distance in a normal curve is 99.73%. They are called 3 sigma limits. So these three values you are supposed to remember. 1 sigma limit covers 68.26% area. 2 sigma limits cover 95.44% area, and 3 sigma limits cover 99.73% area. I think just before this, by mistake I said 68.34. No, it is 68.26%. I'm sorry for that. That is 1 sigma limit cover 68.26% area.
Slide number 9. In the earlier slides, we have discussed the properties of normal curve. That is, 1 sigma limit include 68.26% area or 0.6826 area, and 2 sigma limits cover 95.44% area, and so on. We will see that how we can make use of these properties to obtain the required probabilities or required areas when the value falls on a sigma distance. See this example. You are given that BMI follows normal distribution with mean 24 and SD as 4. That is, mu equal to 24 and sigma equal to 4. If you plot these on normal curve and also plot 1 sigma, 2 sigma, 3 sigma distances, then you know that 24 is the mean, it will in the center, plus 1 sigma, plus 2 sigma, plus 3 sigma. Similarly, minus 1 sigma, minus 2 sigma, and minus 3 sigma. Also, you know the areas between sigma limits, and as the curve is symmetric, for the same distance, area to the right of the mu and to the left of the mu are same. That is, you can split the properties area like for 1 sigma distance, it will be like this, for 2 sigma distance, for 3 sigma distance, and for beyond 3 sigma distance like this. Let us see a question. Question is, what proportion of the population has BMI between 16 and 24? 16 means this perpendicular, and 24 is in the center. That is, you are interested in knowing the area between these two. It's obvious from here. You simply add these two given areas. Also, you can write it as the probability BMI lying between 16 and 24. There is also the area between 16 and 24. Simply add 0.1359 and 0.3413, and you will get the area between 16 and 24 as 0.4772. Because you know the properties, you know these areas. Another question, what proportion of population having BMI more than 28? 28 is at 1 sigma distance on the right side, that is this perpendicular, green one. You are interested in the area to the right of this perpendicular, this area you are looking. Also, you can get it by subtraction. The total area to the left of 24 is 0.5, you know, and from 0.5 you subtract the area of 0.3413, so you will get the required area. That is, from 0.5 subtract 0.3413, you will get 0.1587. Okay. One very important thing here is that For a continuous variable x, probability x less than x, where capital X is the variable, general variable, and small x is a specific value of the variable. The probability x less than x is same as probability x less than equal to x. That is, for continuous variable, there is no difference between less than sign and less than equal to sign. Both are same, both are treated as same. This you have to keep in your mind. Take one more example. What proportion of population has BMI more than 30? More than 30, see where the 30 lies on your in your curve. 30 is between 28 and 32, and you are looking the area above 30. That is, if you draw the perpendicular on 30, you are looking for the area less than above, more than this on the right side of this perpendicular. But this is not, 30 is not at the sigma distance. You don't know this area from the properties. For such type of questions, when the required point is not falling on the sigma distance, we convert our x variable to standard normal form, and then we are having a standard table for that standard normal distribution. We make use of that table to find out the areas of our interest. So now that we are going to do in the following slides. It's very interesting. Once the table is clear to you, you will be very easily computing the required probabilities. Slide number 10. Area under normal curve. Okay. For a normal population, the proportion of values, proportion or percentage of values that that lie between any two observations, say x1 and n2, x1 and x2, is equal to the area above the horizontal axis under the normal curve lying between x1 and x2. What does it mean? Suppose a variable follows normal distribution and the curve is given here, and you are interested, and there are two values x1 and x2 of that variable. This is x1 and x2 is more than x1, that it should be on the right side, is x2. You are interested in knowing what proportion of observations lie between x1 and x2, or what percentage lies between these two. If you draw the perpendicular here, the proportion of values is same as the area below the curve between these two perpendiculars. That is, this area is the proportion of the values. Okay. For example, suppose you are given that height follows normal distribution with some certain mean and certain SD, and you want to know what proportion of persons will be having height between 160 and 170 centimeter. So here your x1 is 160, x2 and x2 is 170, and if you are able to get this area between x1 and x2, that will be the proportion of observations of the persons having the height between 160 and 170. The area between x1 and x2 can be measured by using standard normal table. As I mentioned in the last slide, a standard normal table has been prepared by the statistician. One single table works for all the normal distributions. You may have thousands and lakhs of distribution with different means and different SDs. That standard normal table works for all the normal distributions, and we will discuss how we make use of that table, and we shall be discussing that in the following slides. So this is the main thing, the standard normal table, which we shall be using in in all the numerical problems based on the normal distribution.
Slide number 11. What is standard normal distribution? Normal distribution with mean 0 and variance 1. Variance 1 means SD is also 1 because SD is the square root of positive square root of variance. When the mean of the variable is 0 and SD of the variable or variance of the variable is 1, then the normal distribution is known as standard normal distribution. There is a formula. Okay, we will discuss the formula. Always Z, capital Z is used to denote the standard normal variable. Wherever in literature, in statistics, you see Z, Z means it is standard normal variable, means it is following normal distribution with mean 0 and SD equal to 1. In general, for our variable height, weight, BMI, etc., we use capital X and we call it X. X is the variable. X may be height, maybe weight, maybe blood pressure, maybe hemoglobin, and so on. Z is the standard normal variate. So information available with you is in the form of X, your original variable. We convert our variable to Z form and then we use the table. There is a formula. That is the X axis becomes the Z axis, and any variable X which follows normal distribution with mean mu and SD sigma can be transformed to standard normal variable by the formula Z equal to X minus mu over sigma. Mu is the mean, you know, sigma is the SD. That is, for any X, if mu and sigma is given to you, you can calculate the value of Z. Look, this is the formula which we use in all the questions which are related with normal distribution. In this formula, there are four constants here, 4 values, Z, X, mu, sigma. Usually 3 are given and 4th is to be calculated. In all the normal distribution questions, we are going to use this formula. And if it is a standard normal curve, what will be the mean? Mean, you know, mean is 0 and 1 sigma means 1 because sigma is 1, 2 sigma minus 1 sigma minus 1 plus, that is, these two limits, they are 1 sigma limits, and these two limits will cover 68.26% area, or if you write in proportion, 0.6826 area. And always we use this formula. It's very, very important formula. Again, I am repeating that any variable X which follows normal distribution, it is transformed to a standard normal form by using this formula. Okay. Slide number 12. Transforming normal variable to standard normal variable. As we discussed in the last slide, that our first step when we are dealing with the normally distributed variable, the first step is that we transform it to a standard normal form, and then we use the tables which are available for the standard normal curve. Suppose we are taking an example. Suppose diastolic BP of a population follows normal distribution with mean 80 and SD equal to 8. Okay. And the top curve is belongs to the actual X variable, this, and you are, and the bottom one is after transformation from X to Z, it is the standard normal curve. You are given mean as 80 and SD as 8, and therefore in this curve the points will be, the center point will be 80 plus 1 sigma 88 plus 2 sigma 92 minus 1 sigma 72 and 64. This we have discussed. You know how these are the this is the normal curve. Mean is in the middle. Now the areas also, you know, we have discussed that from the properties of the 1 sigma, 2 sigma and 3 sigma limits. Now Using this formula, z equal to x minus mu, we are going to transform the above x to z. So 80 minus 80 over 8. If you are taking this mu is 80 and x is the different x values. For the central value 80 minus 80 over 8, it will give you the value as 0. 80 minus 80 will be 0. And 88, it will give you value 1. 88 minus 80 over 8, it will give you 1. Similarly, 92 will give you 2. I am not taking the other, simply 3 and 4 like that. What about the 72? All the values of x which are less than mean, they will give you z with minus sign, because if x is less than mu, it will be negative. So this 72 will be minus 1 and this 64 will be minus 2. So this is how we transform the x variable to z variable. Okay. Now areas will remain same. If x equal to 84, 84 is between 80 and 88, you can get the z. For this 84, z will be 84 minus 80 over 8, that is your z will be equal to 0.5. That means 0.5 is somewhere here. So for any x, you can calculate the corresponding value of z by making use of this formula. If x equal to 68, 68 is less than mean, z will be negative. 68 minus 80, 68 is somewhere here between 64 and 72, and it will be negative. When you will calculate it, you will get minus 1.5, that is, it will be somewhere here. So for any x, you can calculate or you can obtain the value of z, and this is what we are going in our following slides. We shall be transforming x to z, and then we shall be answering the question or whatever is required.